Air Force is now testing new, high-tech sensors, software, electronics and other enemy radar evading upgrades for its B-2 stealth bomber to preserve its stealth advantages and enable the aircraft to operate more effectively against increasingly capable modern air defenses. The massive upgrade, designed to improve what's called the bomber's defensive management system, is described by Air Force developers as the most extensive modification effort that the B-2 has attempted. The defensive management system is a technology designed to help the B-2 recognize and elude enemy air defenses, using various antennas, receivers and display processors to detect signals or signatures emanating from ground anti-aircraft weapons, Air Force spokesman Captain Michael Herzog said in a written statement several months ago. The modernized system, called a B-2 DMSM unit, consists of a replacement of legacy DMS subsystems so that the aircraft can be effective against the newest and most lethal enemy air defenses. This system picks up where mission planning ends by integrating a suite of antennas, receivers, and displays that provide real-time situational awareness to aircrew. The DMS modernization program addresses shortcomings within the current DMS system, Herzog added. Upgrades consist of improved antennas with advanced digital electronic support measures, or ESMs, along with software components designed to integrate new technologies with existing B-2 avionics, according to an operational test and evaluation report from the Office of the Secretary of Defense. The idea of the upgrade is, among other things, to inform B-2 crews about the location of enemy air defenses so that they can avoid or maneuver around high-risk areas where the aircraft is more likely to be detected or targeted. The DMSM is used to detect radar emissions from air defenses and provide B-2 air crews with faster mission planning information while in flight. Air Force officials explain that while many of the details of the upgraded DMSM unit are not available for security reasons, the improved system does allow the stealthy B-2 to operate more successfully in more high-threat, high-tech environments, referred to by Air Force strategists as highly contested environments. Many experts have explained that 1980s stealth technology is known to be less effective against the best-made current and emerging air defenses. Newer, more integrated systems use faster processors, digital networking and a wider range of detection frequencies. Upon its inception, the B-2 was engineered to go against and defeat Soviet air defenses during the Cold War. The idea was to operate above enemy airspace, conduct attack missions and then return without the adversary even knowing the aircraft was there. This mission, designed to destroy enemy air defenses, was designed to open up a safety zone or air corridor for other, less stealthy aircraft to conduct attacks. In order to accomplish this, B-2 stealth technology was designed to elude lower-frequency surveillance radar, which can detect the presence of an aircraft, as well as higher-frequency engagement radar precise enough to allow air defenses to track, target and destroy attacking aircraft, developers explained. It is widely believed that modern air defenses such as these are now able to detect many stealth aircraft, therefore complicating the operational equation for bombers such as the B-2, senior Air Force officials have acknowledged. These newer air defense technologies are exhibited in some of the most advanced Russian-built systems such as the S-300 and S-400. In fact, according to a report from Dave Majender in the National Interest in Reports in the Russian media, the Russians are now engineering a new, more effective S-500 system able to hit some stealthy targets out to 125 miles or further. In fact, the National Interest once cited a Russian media report claiming that stealth technology was no longer useful or relevant, a claim that is not believed to be true at all, or is at least unambiguously disputed by many experts and developers familiar with stealth technology. For this reason, many senior Air Force developers have explained that, moving into the future, stealth technology is merely one arrow in a metaphorical quiver of offensive attack capabilities used by the B-2. Nonetheless, Herzog explained that upgraded B-2 stealth technology will have a much improved operating ability and strategic advantage against a vastly wider range of air defenses. With necessary upgrades, the B-2 can perform its mission regardless of location, return to base safely, and permit freedom of movement for follow-on forces, including other long-range strike platforms. Modifications such as the DMSM are necessary to preserve this strategic advantage against 21st-century threats, Herzog added. The DMSM upgrade does not in any way diminish the stealth properties of the aircraft, meaning it does not alter the contours of the fuselage or change the heat signature to a degree that it would make the bomber more susceptible to enemy radar, developers said. Many advanced air defenses use X-band radar, a high-frequency, short-wavelength signal able to deliver a high-resolution imaging radar such as that for targeting. S-band frequency, which operates from 2 to 4 GHz, is also used by many air defenses, among other frequencies. X-band radar operates from 8 to 12 GHz. Synthetic aperture radar, or SAR, sends forward an electromagnetic ping before analyzing the return signal to determine shape, speed, size and location of an enemy threat. SAR paints a rendering of sorts of a given target area. X-band provides both precision tracking as well as horizon scans or searches. Stealth technology, therefore, uses certain contour configurations and radar-absorbing coating materials to confuse earthward electromagnetic signals from air defenses. These techniques are, in many cases, engineered to work in tandem with IR, infrared, suppressors used to minimize or remove a heat signature detectable by air defenses' IR radar sensors. Heat coming from the exhaust engine of an aircraft can provide air defense systems with indication that an aircraft is operating overhead. These stealth technologies are intended to allow stealth bomber to generate little or no return radar signal, giving air-dense operators an incomplete, non-existent or inaccurate representation of an object flying overhead. Also, the B-2 is slated to fly alongside the service's emerging B-21 Raider next-generation stealth bomber. This platform, to be ready in the mid-2020s, is said by many Air Force developers to include a new generation of stealth technologies vastly expanding the current operational ranges and abilities of existing stealth bombers. In fact, Air Force leaders have said that the B-21 will be able to hold any target in the world at risk, anytime. While many senior Air Force officials have made this point in recent years, the ability of the B-21 to strike anywhere in the world was something emphasized by Lieutenant General Arnold Bunch, Military Deputy, Office of the Assistant Secretary of the Air Force for Acquisition, told U.S. Military News Channel last year in an exclusive interview. Naturally, many of the details of these stealth innovations are, by design, not available for public discussion, according to Air Force and Northrop Grumman developers. The DMSM program achieved a key acquisition milestone last year, authorizing the program to enter what's called the Engineering, Manufacturing and Development (EMD) phase. Major efforts during the EMD phase include the system critical design review, completion of hardware and software development efforts, integrated test, and initial operational test and evaluation. 3 aircraft will be modified during EMD to support the successful completion of this phase, Herzog explained. The program plans on achieving 2019 full-rate production following this phase in 2019. The total research development, test and evaluation funding for B-2 DMSM is $1.837 billion to develop 4 units, Herzog added. The B-2 is engineered and built by Northrop Grumman. The major subcontractors on the program are BAE, Receivers, Ball Aerospace and L3 Rantern, Antennas, and Lockheed Martin, Display Processors. Total procurement funding for the B-2 DMSM program is $832 million to procure 16 additional units. The Air Force currently operates 20 B-2 bombers, with the majority of them based at Whiteman AFB in Missouri. The B-2 can reach altitudes of 50,000 feet and carry 40,000 pounds of payload, including both conventional and nuclear weapons. The aircraft, which entered service in the 1980s, has flown missions over Iraq, Libya and Afghanistan. In fact, given its ability to fly as many as 6,000 nautical miles without need to refuel, the B-2 flew from Missouri all the way to an island off the coast of India called Diego Garcia, before launching bombing missions over Afghanistan.